All right, section 5.5a, we're going to do A and B today. For 5.5a, we're going to be doing function operations. So we're going to be adding, subtracting, multiplying, and dividing functions, okay? So when we are adding the functions, you're going to see it in this format. F plus g, f is a function, g is a different function, and we are adding them together. So just think about this as combining like terms, okay? Same thing, we could ask you to subtract f minus g. What's important here is to follow the order. So if I were to give you g minus f, you obviously would put the function of g first and then f, okay? And then with subtraction, it is important to distribute the negative. That's going to make a difference in our answer. The product just means multiply, so I could say f times g of x, and that means I'm going to take f of x and g of x, and I'm going to multiply them together. And lastly, I have quotient, so I'm going to be dividing f divided by g. There is one restriction on this one. We cannot have a 0 in the denominator. So our value in the denominator cannot be 0. So we're going to have to apply that restriction. What would make the denominator 0, and then state that those are the values that x cannot equal. Okay? So let's go ahead and jump into an example. Find each of the following for the function. So you can see that we're going to be adding, subtracting, multiplying, and dividing here. Let's start off by adding them together. So again, for adding, it doesn't really matter if you follow the same order, but this just means that we're going to take the function of f of x, and I'm going to add it to the function g of x. So writing down what f of x equals, I have 2x minus 1 plus, and then g of x is all of this, x squared plus x minus 2. Now, the reason why I'm putting it in parentheses is because if there was something in front of the parentheses, I would want to distribute that. In this case, it's just 1, so it's not really going to affect anything, right? So I'm just going to rewrite this. And then for the plus, technically when I distribute the plus, nothing changes again. It's just plus x squared plus x minus 2. So if in your if moving forward you want to skip that step of putting the parentheses, that's fine for adding only, because it will make a difference in subtracting, as you will see here in a moment, okay? So I'm going to combine like terms, starting with my highest exponent. X squared cannot combine with anything else, so that's going to just be x squared. And then I have 2x plus 1x, that's going to give me 3x. And lastly, negative 1 minus 2 gives me negative 3. And right now, that's all we're asking you to do. You are just going to add these together, okay? Now, for subtracting, again, it matters that you follow the correct order. So in this case, I want to subtract f minus g of x. So I'm taking f and subtracting g of x. If it were in the opposite order, you would just write these in the opposite order here. So again, looking at, is there anything to distribute in the front? Technically, there's just a 1 here, so nothing changes. But with the minus, when I start distributing that through, I get negative x squared minus x plus 2. So then I'm able to combine like terms. Negative, make sure you bring that sign with you. Negative x squared, and then I have 2x minus 1x gives me a positive 1x. And then negative 1 plus 2 gives me a plus 1. So this would be my answer. So again, it is really important that for subtracting, you write it in parentheses so you don't forget to distribute that minus to everything in the second function. Okay? Now, this means multiply. F times g of x means that we're going to take our 2x minus 1, our f of x function, and we're going to multiply it by g of x, x squared plus x minus 2. So this is double distribution. I'm going to take 2x and multiply it by everything on the other function, which gives me 2x to the third plus 2x squared minus 4x. And I'm going to do the same thing with my negative 1 minus x squared minus x plus 2. Negative and negative is a plus, okay? So then combine your like terms. I have a 2x cubed, which can't combine with anything, so it just stays the same. Then I have a positive 2x squared and a minus 1x squared. That's going to give me just 1x squared. The 1 is not necessary there if you don't want to put it. Then I have a negative 4x minus 1x becomes more negative, so negative 5x. And then the plus 2 doesn't combine with anything else, okay? So this is my final answer. Just make sure you combine like terms and simplify if needed. Okay. Lastly, we want to divide, and for when we are dividing, we just have to remember that there are restrictions for the division part of this. So I'm going to start off by writing again, f is on top, so 2x minus 1 over my denominator is the g of x function. And I have to know which values would make the denominator 0. So I need to essentially set the denominator equal to 0. I'm going to factor the denominator to figure this out, and I get x plus 2, x minus 1 in my denominator. So think about, if you set these factors equal to 0, what would be the values that make the denominator 0? If I set x plus 2 equals 0, x comes out to be negative 2. And if I set x minus 1 equal to 0, x comes out to be 1. So these are the values that x cannot equal, because if either of these equals 0, either of these factors equals 0, then it's going to make the entire denominator equal to 0, and that cannot happen for the division ones. So I have to say that this is my answer when I simplify, but also x cannot be 1 or negative 2. We have to state that as part of our answer when we are dividing, and there has to be a restriction in the denominator to figure out what value the denominator cannot be. Okay? All right, let's go on to the next example. So same process. We are going to add, subtract, multiply, and divide. So for adding again, we talked about how the parentheses don't really matter. I'm just going to write them to get you used to that because it makes a difference for subtraction. So let's just keep it consistent. I'm going to combine my like terms. X squared doesn't combine with anything, so I just get x squared there. Then I have 7x and 5x, so that's 12x. And then 10 minus 3 is a positive 7. Okay, and that's my answer for the addition portion of this. Subtracting, I'm going to write f of x first, so that's x squared plus 7x plus 10. And I'm subtracting g of x, 5x minus 3. So this is where it's important that I distribute that negative, as it'll change the signs, okay? And then go ahead and just combine like terms. So again, x squared can't combine with anything. But then I have a 7x and a negative 5x, so that's a positive 2x. And then 10 plus 3 gives me 13. Okay. Now we're going to multiply them together. So remember, that just means you are distributing through the values. So I have my f times my g and distribute. So multiply it through. X squared times 5x is 5x to the third, and then minus 3x squared. And then do it again for the 7x. So 7x and 5x is positive 35x squared minus 21x. And then one more time with the 10 plus 50x minus 30. Okay, combine your like terms. Your 5x cubed doesn't combine with anything. But then I have negative 3x squared plus 35x squared gives me 32x squared. And then I have 21x, or negative 21x plus 50x gives me a positive 29x. And then the negative 30 cannot combine with anything. So this is my answer here. All right. Last one, division. So remember, the division one is where you need to look for what the denominator cannot equal. So in this case, I'm putting f in the numerator, x squared plus 7x plus 10. In the denominator, I have 5x minus 3. We're going to go ahead and try to factor both the numerator and denominator. So the numerator factors out to this, and the denominator can't be factored. But I still need to figure out what would make the denominator 0. So if I set 5x minus 3 equal to 0, and I solve for x, I get x equals 3/5. So in addition to my answer, I also have to say x cannot equal 3/5, because if x were to equal 3/5, that would make my denominator 0, and I don't want that. Okay? All right, last example here for this first part of the notes. We have some fractions for the exponents, so we have worked with this before. It's fine. We're going to go ahead and add them together. So f of x is 4, x to the 1/2, plus the negative 9, x to the 1/2. Now, because our base of x has the same exponent, I can simply just combine the coefficients. So 4 and negative 9 gives me a negative 5, x to the 1/2. You could also technically see this as negative 5 square root of x, but we can just leave it like this for now. That's perfectly fine. Okay. Moving on to the subtracting, again, we have f of x in the front. So 4x to the 1/2 minus negative 9x to the 1/2. This double negative is going to become a plus. And again, I have the same, that's a 1/2. I have the same x and the same exponent, so I can just go ahead and combine like terms. 4 and 9 is 13, x to the 1/2. When I am multiplying, and here's where your knowledge about exponents comes in handy, remember when you multiply exponents, so I'm going to write down my functions, they're going to be multiplied. What happens to the exponent when the terms are being multiplied? We actually end up adding them. So I'm going to multiply the 4 times the negative 9 like normal, negative 36. And the x is going to stay the same, but think about what happens to the exponents. We're actually adding them up. 1/2 plus 1/2 is 2/2, or just 1. So there's actually a 1 right there. Not necessary that you write it, but there is 1. Okay. And last one here, we have division. So 4, x to the 1/2 over negative 9, x to the 1/2. So again, think about your rules for when you are dividing terms with exponents. You are actually going to subtract 1/2 minus the 1/2, gives you 0. So this cancels out, right? Because it would become x to the 0 power, which is just 1. So this is 4 over negative 9. Now, remember, there has to be a restriction anytime we deal with a fraction. So even though there is no x in our final answer because it cancels out, if I go back here, I need to remember to say that x has to be greater than 0 no matter what. So it always helps to add that little piece with every answer. So you should have some sort of restriction, tell us what x cannot equal. And if things cancel out like here where they simplify, you still should state that if I were to go back to the previous step, x still needs to be greater than 0, okay? All right, now we're going to talk about the second part of the notes, which is composite functions. And composite functions just mean that we are incorporating one function into another. So similarly to when we have you substitute in for x, we're going to have you substitute in for an x value, but instead you are going to substitute g of x, an entire function, anywhere we see x in the f of x function, okay? And these could be flipped. So again, we're replacing every x value of the first function. So whatever is first, this is the function that we keep. And the second function is the one we replace x with, okay? So we're just creating a new function essentially by replacing the x with a different function. And this will make more sense once we actually start doing the examples. So for this first example, again, the first one is the one we're going to keep. So we are going to keep this function, 3x minus 4, but instead of writing x, I'm going to replace the x value. So again, I'm just writing f of x but not x. And I'm going to replace the x value with the second function, g of x. So this is going to go in here. X squared minus 2x plus 6. Okay, that's what composite functions are. We are substituting and then distributing and simplifying. So I'm going to distribute. That gives me 3x squared minus 6x plus 18, and then minus 4. So finish that up by simplifying. 3x squared minus 6x plus 14. And that's my answer here. So that's all it's asking me to do so far is create a new function, create a composite function once I replace any x value with another function. That's what we're doing here. Okay? We could also ask you to do it in the opposite way. So in this case, I could ask you to keep g of x. So we're going to keep the x squared minus 2x plus 6, looking at the same example. And this time replacing the x with f, okay? So I'm going to write my g of x anywhere I see x's. I'm just going to leave them as parentheses for now. Parentheses. And then this means take the f of x function, and that's what goes in those parentheses. So I'm going to bring it over, and that's 3x minus 4, 3x minus 4. And then go ahead and simplify from there, okay? So this means multiply 3x minus 4 by itself. And when I do that, I get 9x squared minus 24x plus 16. This means distribute the negative 2, which gives me negative 6x plus 8. And then bring down that plus 6, okay? And now we just combine like terms and simplify. So 9x squared cannot combine it with anything. So then I have negative 24x minus 6x is negative 30x. And then 16 plus 8 plus 6 gives me positive 30. And that's my answer. That's your new function, g of f of x. And the last part is actually asking us to use that answer, g of f of x, this one, and replace the x's with the 1. So this time I want an actual answer, okay? So looking at the difference between what it'll ask you, if it just says g of f of x or f of g of x, it wants you to leave the answer in terms of x. But when there's an actual number like there is here, g of f of 1, it means find g of f and then replace the x's with the 1. So again, I'm using that same function I just came up with by doing g of f of x, and then I'm substituting in any x's with the 1. So use your calculator to simplify that, and you should get 9 as your answer. Okay, so that's what we get when we replace 1 for the g of f of x function. All right, let's go to example number 2. And same process. The first function tells me which one I'm going to keep. So I'm going to keep, in this first one, f of x. So I have 5. I'm replacing the x with the opposite function. In this case, that opposite function is g of x is all of that. So I'm going to write that in here in place of my x. Go ahead and distribute to simplify this. So we get 10x squared minus 5x minus 5. And then bring down the plus 6. Combine like terms and simplify. 10x squared minus 5x stay the same. And then we have negative 5 plus 6, which is 1. And that's your answer. That's your new function. Okay. Next we have g of f of x. So the opposite, we're going to keep the g function and we're going to replace the x's with the f function. So I have 2 big parentheses squared minus parentheses minus 1. And then I'm going to replace those parentheses with the f function. So 5x plus 6 goes here and here. Okay. Now this one we just have to be careful that we follow the order of operations. So let's simplify what's inside the parentheses first. That means we need to multiply 5x plus 6 times 5x plus 6. Okay, when I do that, I get 25x squared plus 60x plus 36. So that goes in that parentheses. Just take it one step at a time. And then I'm going to distribute that 2 here next. Okay, when I distribute the 2, I get 50x squared plus 120x plus 72. And then we still need to take care of the rest of this. So this minus needs to be distributed. So I have a minus 5x, minus 6, and then this minus 1 can just come down. Combine like terms. 50x squared cannot combine with anything. But then I have 120x minus 5x gives me plus 115x. 72 minus 6 minus 1 gives me, that's technically minus 7, so positive 65. And that is your answer. That's your new function. Okay. So part C, again, asks us to use the previous answer, g of f of -1. So again, because there's a -1 there instead of an x, we know that our final answer should be an actual number, not just in terms of x, okay? So I'm using this one, and I'm replacing the x with the -1 squared, or -1, sorry, that's squared for that one. Okay. And use your calculator, and you should just get 0 as your answer here. Okay. Last example for this set of notes does involve some fractions. So this one, just make sure you're going slowly, and we'll get through it. So first, f of g of x, we're going to keep the f function. So that's 27x to the 2/3, and remember we're going to replace that x with the g of x function. So in this case, I'm replacing that with 3 over x. Okay, so for this one, we have to keep in mind that we need to distribute this exponent, that's an exponent technically, to everything inside the parentheses. When I do that, I get 3 to the 2/3 power over x to the 2/3 power. Using the knowledge for exponents, I know that I can rewrite that as this is going to be my in, this is my out, my in, my out, so that's 27. Now technically you could enter this in the calculator, finding the cube root of 3 squared and then cube root of x squared. Okay, now this is, and again, I'm doing more steps probably than you will need to do. I just want you to see every single one. So we still have the 27 in the front. That's going to be multiplied by 3, or cube root of 3 squared, which is 9. And then in the denominator, we still have the 3 square root of 3 x squared. Cube root of x squared, sorry. So we don't like radicals in the denominator, okay? So the way we get rid of that radical in the denominator is if we multiply by the exact same radical to the numerator and denominator. So that's the cube root, so I'm going to multiply by the cube root of x in the numerator and in the denominator. And when I combine these, I have 27 times the cube root of 9 times the cube root of x over, and the whole point was for me to get rid of the radical. So what's technically happening here, let me take you off to the side. This is the same thing as x to the 2/3 times x to the 1/3. what happens to the exponents is they get added up and they turn into 1. So then the radical goes away and I just get x to the first power, so x, okay? And then looking at this step, because they both have the same cube root, I can turn them into one term. So all of this can be simplified to 27 cube root of 9x over x. And I can't simplify that anymore, so I'm going to just leave it right there. Okay? Now we're going to do the g of f of x. So opposite way, we're going to keep g, which in this case is 3 over x, and my x becomes the f of x function. So 27x to the 2/3. So same process. I'm going to simplify this a little bit. This is what's inside, this is what's outside. So I really have 3 over 27 cube root of x squared. Now the 3 and the 27 can simplify. I can divide both of those by 3. So divide by 3, divide by 3, and that gives me 1 over 9. And then I still have the cube root of x squared, okay? So same process, I don't want a radical in the denominator, so I'm going to multiply both the numerator and the denominator by the cube root of x. And that's going to give me cube root of x in the numerator, and the denominator is going to give me a 9 still, and then just x. Because again, what's happening here, this means that I have x to the 2/3 times x to the 1/3, which is x to the 3 over 3, which is just x. So that's how I get just x there. And I can't really simplify this anymore, so this is my final answer. And lastly is using that g of f again and substituting in -1 for x. So I'm using that answer that I got for the previous one, and I am replacing any x value with the -1. Okay. When you take the cube root of -1, we get -1, and 9 times -1 is -9. Negatives cancel out. My final answer is just positive 1/9. Okay, and this is the end of our note. So just be careful which one you are replacing, which one you are keeping, and then remember that if it's asking you for g of f of a number or f of g of a number, your final answer should be a number, as opposed to when it still says in terms of x, then your answer should still be in terms of x. Okay?